Hi and welcome back to a new video, and this time I'd like to introduce the new asset which is already available in the Unity Asset Store called SensorCamera. With this asset it's easy to create camera-based light detection like you can see in tower defense games or in stealth games, and in this video I'd like to explain how this asset works, how you can configure it, and how the demo scenes work. So first of all, let's start with a small showcase. I'm just starting the first demo scene, and as we can see, the cube is moving. I'll just activate the gizmos in the game view and we'll see the red ray indicates that the object is hidden, the green ray indicates that the object is seen from the camera by the camera, and as soon as the cube leaves the camera frustum, it's not detected anymore. Just activating all the log messages, and as you can see, the cube moves in again, goes behind a wall, is no longer detected, and as soon as it's visible within the view frustum, the green ray appears, and as it leaves the view frustum, it's gone again. This is the very simple approach. It's purely raycast based and requires a small amount of configuration. There's no coding for you to do and no extra settings to set up. Let's go on to the second demo, which is called the single object demo, and this showcases everything you can do with the SensorCamera. So first of all, on the left side there's the raycast. No raycast collider only approach. In the center is raycast and collider mixed, and on the third place is the raycast only with no collider. So just starting up the demo scene. Here we can see that the collider only approach always detects the cube as soon as it enters the frustum and stops moving as soon as the cube leaves the frustum. The raycasts combined or the raycast only solutions work differently. As soon as the cube is not visible anymore, so it's occluded by an object like the wall here, the camera will stop tracking. That's some kind of basic tower defense-like approach with occlusion, or in the collider only case with no occlusion. And how does it work? Let's just have a look at the quick setup. As soon as you select the SensorCamera object, you'll see that the camera is deactivated. The SensorCamera script is in this case set up for only using collision based. There is a collision mask, and the events that are triggered on found and no object detected will be triggered by a turret script, which is here. The code and everything else is included in the Unity package in the samples, and this is basically only for controlling the camera rotation, but the detection is handled by the SensorCamera, and as you can see, there's a collision-based approach here with the mesh collider. Going over to the raycast and collision, there is the only setup difference that made here is that the use raycast checkbox is activated, and the events again will control the turret rotation. When going over to the raycast only approach, we'll see that there is no mesh collider here, so there is no collision, and it's only using the raycast system and the special setting which should be used for using without the collider here, so it's referencing the object that should be detected. On the object itself is a tracker, here the SensorCamera tracker, which is on every object which should be tracked by the SensorCamera. Now this approach is suitable for tower defense or for stealth games. Especially in tower defense games you will have multiple objects that should be detected by the camera. There is the second demo, the multiple object demo, where the white cylinder here is a spawner and the turrets will detect spawned objects by collision only. And there are two different modes when it comes to collision: to target every incoming object and to target every outgoing object. As we will see in a second, the first one will always keep its targets on the left side because it's always targeting the next thing that comes within view. And on the right side, it will more or less lean to the right side because it's only targeting the outgoing objects. So let's have a look. As you can see, there are objects spawned, and the first turret will always switch to the next incoming object. And on the right side, the second turret will always keep its goal to the last object that was within the view. And as this is collider based, as you can see here, the object is leaving the frustum very late, so that the targeting mode does actually make a difference in targeting objects, especially when it comes to shooting or something else. And if we would look at the setup of the sensor camera here, it's basically the same as before. No raycast. The option for first in, first target is set on the left side, where the collision mask. No debug razor messages, just to keep the console clean. No object set, and on found object, rotate the turret towards my enemy. And if there is no object detected, this means that the object left the first frustum. Make it basically stop rotating, and in this case it's used to delete the last object that was in view. Same goes for the second turret, which only has one difference, that the first in, first target object is not set, so it will always target the last object. And something that may be not visible here, we have to go into the scene view for this. The detection is working in 3D, so there is no pure 2Ds. Everything that's within the frustum mesh will be detected, and the camera will look at it. In this case, as we configure the turret like this, you can also use this for stationary cameras or something else, or even for enemies in a stealth game, which will spot the player when he is sneaking into the castle or something like this. Which brings us to the next demo, the tower defense demo. And this demo is a very, very small prototype of a tower defense game where cubes will spawn on the right side, on the right cube, will make their way through the towers and will be destroyed if they ever reach it here, and the towers will shoot at them and reduce their health. Let's have a look. So we'll see that blue enemies are spawned, the turrets are detecting them, and you see the bullets here. They're shooting at them, always dealing damage, and the longer the cubes progress, the more turrets will fire on them, and it's basically designed that the objects will never make it to the goal. There may be a coincidence that they will make it, but it doesn't matter. So as you can see here, the detection works pretty good. This is basically a tower defense game. There are various settings for how you can configure these turrets, and for instance, one thing you can see, the turrets will never return to center. As soon as they lost the tracking, you can see briefly here, they will stop moving at all. So, but that's not a problem at all. You can configure that. There are sample scripts for turrets, and that's the tower defense sample. Another very popular approach is a stealth game, and we have a stealth demo here with 1, 2, 3, 4 security cameras with very big view frustums, which will try to detect the player, which is the white cube. The white cube will have to reach the blue cubes here, all two, to activate the exit. And the cameras will also have some kind of alert state, and the player will have a safe point in here, in this corner, where no camera can see him, even if they tracked him. So he's hiding, and after 5 seconds of hiding, the cameras will start to operate again in a usual manner, like turning from here to there. This is only an example, so you can always add your own scripts, but the camera detection itself is the same. And let's see how this is playable. I'll just start the scene, switch to game view. I'll just maximize the window here. So this is a stealth demo. I can zoom in and zoom out with the mouse wheel. I can move around with WASD. And as we can see, as soon as I get into the view frustum of the camera, I'm found. And I can do this with multiple cameras here, 1, 2, and 3 cameras. And the camera will, as soon as it loses track of me, the camera on the right side now, this one here, will lose track. The ray will turn red, and it will take 5 seconds to work again. And I can just hide over here to do the same, so no camera does see me, I'm hidden, and after 5 seconds all the cameras will operate again in normal manner. So let's try to play this like a real stealth game without getting noticed by any of the cameras. Here we go. Just delete that, go to the first blue switch, go down here, go here, wait here a second, evade that, evade the next one, tack, and as you see here, the red exit is here, and as soon as I'm free I can get here and have success. Nice. So that's the demo with the security cameras, and the setup is pretty similar to everything we saw here, with the recasting and the collider approach. I have my events, and the scripts behind them are managing some kind of alert state. And you can do the same as here without having to rely on recasting too, without having to rely on colliders too, like there's the last demo. This has no colliders at all, so the security cameras don't have any collider here, it's just a mesh for visualization. And if I play this now, I'll maximize again, and as you can see here, moving the mouse moves the camera, zooming out, zooming in with mouse wheel, and WASD for moving around, and there is no collider this time, it's purely recasted. So as soon as I go into there, I'm found. As soon as I'm not visible again and I'm peeking, I'm hidden. And after 5 seconds, the cameras will operate. So just play the demo through. First blue. You can see here very nicely that the camera is following me. Get to the second blue. I'm hidden now as I evaded the third camera, waiting for everything to settle down. And now sprinting to the exit. Success. So that's it, and I guess it's now time to start from scratch and show you how to set everything up. We're creating a new scene, call it test scene. And here's everything starting from scratch. I'm adding a new game object, let's call it SensorCamera. Move it to the origin. Let's go down here. We won't need the camera, basically the main camera, but it doesn't matter at the moment. Let's add the sensor camera options for easy setup. So we now have here a camera, we can disable that, we don't need it, doesn't matter if it's enabled or not. And with the sensor camera script here, so first of all I'm dragging my camera to the watcher camera, and as you can see the camera frustum is now displayed differently, and I'll just change that to, let's say, near plane of 1 and the far plane of 4. So in this area the scanning will happen. Basically there's nothing else to do now, as we will start with the recast based detection. We have here the events. Just as a side note, if you want to do something with the events, I'll just create another empty game object, reset it, call it logger. You can just create a simple script like this, where debug messages are being displayed, added to the mono behavior here, and to the event listeners. Let's say this is the logger. And every time doing something, we want to just one being found, one being hidden, one disappear. Just for logging purposes, cleaning the console here. And we want to use the raycasting, no collider for now. And we want to create an object that should be detected. Let's create a cube, reset it, move it to, I don't know, 3. Let's move up a little bit and stay in the scene view, just for better testing. And the cube will get a sensor camera tracker, which has objects too, one being found, one being hidden, and so on. So and this class is basically for just tracking everything. We can just say, okay, we want to have that 2 logged, reference the logger here. Doesn't matter in this case, being found, being hidden, disappear. And when we now start the scene, everything is properly set up, and we now have to reference our cube object here because we're not using any colliders. And if we now start the scene, we see that logger is being found by the cube camera, logger is being found by the sensor camera, which basically is this script here, as it's on the logger object. You place this usually on the tracked object, but this doesn't matter in this case. And as soon as we move the cube out of the frustum, we left the frustum, and both the camera and the cube will tell us that they are that's no longer visible. Just enabling the debug rays. And when the cube now moves back into the frustum, we have a ray here. And when it moves out, the ray is gone. And if we stay here, let's just go back here, apply that setting here, and add some other cube, call it wall, reset the position, let's scale it up to 2, this could be 0.1, and move it a little bit over here so that it's like a wall that's occluding our player cube. You can also add something like a rigid body here or something that's, for testing reasons, it's not needed. And we press play again, and we see that the cube is now detected. As soon as it's behind the wall, it's no longer detected. It's still in view because it's hidden, but it's no longer detected. And when it moves out, it's lost. Something like this. You can also do it like this. As we saw before, the peeking is possible. So if we go over here and check the view from within our cube, we can still go farther down here like this and peek around the corner without being detected by the camera. So far so good. That's the raycasting approach. And if we want to now go with collisions, we just go over to the sensor camera, to the sensor camera options, show the frustum collider options, checkbox, choose a material. There's a material called camera frustum here. Click on add sensor camera collider. And as you can see, there's a mesh now with a collider around it, which will work for our trigger collider. And as soon as we're working with colliders, we have to be aware that there are layers that the collider works on, and these layers will control how the camera is working. And instead of setting all the layer options within the project settings, let's just go with this. As soon as you add the camera collider, everything is added to the ignore raycast layer, and just tell the camera it should ignore everything what is on the ignore raycast layer, so no collision happens between the mesh collider of the camera frustum and the raycast that it's sent from the camera. And we have to tell our sensor camera on which layer are the objects that we should detect. In this case, our cube is on the default layer, the wall 2, but only the cube has the tracker. So they can be on the same layer, but only the object with the tracker is tracked. That's some kind of double check here. Go to the sensor camera. Collision mask is the default mask. You can also choose multiple masks here. It will go with the default mask here. Remove the reference for the intruder object. It's no longer needed. The cube has no rigid body. So when dealing with collision-based detection, you will have to add a rigid body. For easier movement, we'll just untick the use gravity. I'll move it up a little bit. Leave all the default settings and then start the scene. And as we now see, the cube is detected. Now it's hidden because this is not the object we're looking for. And as soon as we leave the frustum, everything is working as it was before. And that's basically how you build tower defense or stealth games or everything else which needs detection within a certain view frustum with sensor camera. I hope you had fun. I hope this was informative. Please consider becoming a channel member to get access to this source code and the project you see here. Otherwise, you can buy it on the Unity Asset Store. The link is in the description box. Please like and subscribe. There are many more assets to come. We're working on quite some stuff now. And comment for further questions. And don't forget to leave a positive rating or a favor on the Unity Asset Store site. So thank you for watching. I'll see you soon. Goodbye.